Hello and welcome to the podcast where we explore the innovations shaping our future. Today, we're diving into a world that sounds like science fiction, but is rapidly becoming science fact. Imagine materials that can make objects invisible, or supercharge medical scans to see inside our bodies like never before, or even help us harvest energy from the air around us. Sound impossible? Not with metamaterials. So what exactly are these wonder materials? Essentially, metamaterials are not things you dig out of the ground. They are engineered structures, designed by humans, often at the tiniest scales. Think nanoscale. Scientists take everyday materials like metals, plastics, or even ceramics, and then they manipulate their internal architecture. This precise design gives them extraordinary abilities, properties you just don't find in nature. How do they achieve these superpowers? It's all about how their unique subwavelength structures interact with different kinds of waves. Electromagnetic waves like light, sound waves, or even seismic waves from earthquakes. One of the most mind-bending properties is a negative refractive index. This means they can bend light in ways that conventional materials simply can't, which is the secret sauce behind ideas like superlenses, and yes, even cloaking devices. They can also precisely control electromagnetic waves, which is huge for things like antenna technology. Think smaller, more efficient antennas for 5G and beyond. Now let's talk applications, because this is where it gets really exciting. Take magnetic resonance imaging, or MRI. We all know MRIs are crucial for doctors, but they can be slow, and sometimes the images aren't as clear as we'd like. Metamaterials are changing that. They can dramatically improve the signal-to-noise ratio, leading to higher resolution images for more accurate diagnoses. This could also mean shorter scan times, a big relief for anyone who's been in an MRI tube. And get this, scientists are developing lightweight, flexible, even wearable metamaterials, perhaps woven into textiles, that conform to your body. This not only improves comfort, but also image quality, and some can even shield organs from unwanted radiation. Plus, researchers are using low-cost materials, potentially making MRI technology more affordable and accessible globally. Next up, energy. Metamaterials offer incredible potential for a greener future. Imagine materials that can efficiently convert ambient energy, like stray electromagnetic waves, sound, or vibrations, into electricity. Some metamaterials can even provide cooling without using any power by radiating heat away from buildings or electronics, even in direct sunlight. And for storing energy, new mechanical metamaterials can store and release elastic energy at much higher levels than normal materials, which could be revolutionary for robotics or shock absorption. Then there's wireless communication. Metamaterials are already helping to boost 5G networks by making antennas more efficient. Special surfaces made from metamaterials, called reconfigurable intelligent surfaces, can cleverly reflect and redirect signals for better indoor coverage, potentially reducing the need for so many cell towers. And what about those sci-fi dreams? While full invisibility cloaks are still in the lab, the ability of metamaterials to redirect light holds promise. For more immediate impact, think earthquake protection. Metamaterials incorporated into building materials could significantly improve structural safety by dampening seismic waves. They're also being used for super-sensitive sensors, noise cancellation, and creating ultra-thin optical devices for things like medical imaging and advanced communications. So what's next for metamaterials? The field is exploding, thanks to advances in AI-driven design, powerful simulation tools, and new fabrication techniques like 3D printing and nanotechnology. Scientists are constantly exploring new designs to unlock even more sophisticated functions, aiming for smart metamaterials that can adapt to changing conditions. Of course, there are challenges. Making these materials on a large scale, with the precision needed, and integrating them into existing technologies isn't always easy. But with scientists from so many different fields working together, the future looks incredibly bright. We're talking about innovations that could genuinely tackle global challenges in healthcare, energy, and communications. Keep an eye out for conferences like Meta 2025 and Metamaterials 2025 next year, where the latest breakthroughs will be unveiled. That's all the time we have for today. Join us next time as we continue to explore the cutting edge of science and technology. Thanks for listening.